Hello viewers, I welcome you all for the video lecture on operating systems and virtualization. The topic to be discussed for the lecture video is system calls, system programs, design and implementation. Let's have the introduction, overview of system calls, system programs, and operating system design. System calls act as the interface between user-level applications and the kernel. System programs enhance operating system functionality and usability. Focus on efficiency, security, reliability, modularity, and concurrency. What are system calls? It is an interface between user programs and the OS kernel. It is used to request services like hardware access, file operations, and process management. It ensures controlled and secure access to system resources. Purpose of system calls. It includes resource management, manage memory, CPU input and output, hardware abstraction, device-independent operations, security and protection, access validation and enforcement. Inter-process communication. It enables inter-process communication mechanisms. Types of system calls. Process management, file management, memory management, device management, information maintenance, communication, security. Examples of system calls is shared here. How system calls work. User program invokes a system call. CPU switches from user mode to kernel mode. Kernel identifies system call number. System call handler executes required action. Kernel return results switch back to user mode. System programs, utilities that support operating system functions but run in user space. Provides tools for management, user interface, networking, and software development. Purpose of system programs. System resource management, file manipulation, development support, the compilers and debuggers. User interfaces, CLI and GUI. Networking and configuration, backup and restore operations. Understanding system components. In the picture representation. Types of system programs. File utilities, process utilities, editors, compilers and interpreters, shells, configuration tools, and backup utilities. Relationship between system calls and programs. System programs rely on system calls to interact with OS resources. Example, CPU is open, read, write internally. System programs provide high-level functionality. System calls provide low-level access. Design considerations. Minimize mode switch overhead. Optimize kernel execution paths. Use caching to reduce repeated computations. Design considerations. Input validation for every system call. Robust access control enforcement. Privilege separation for system utilities. System considerations. Graceful error handling and robust written codes prevent resource exhaustion. Comprehensive testing for kernel and utilities. Concurrency considerations. Synchronization to protect shared resources. Locking mechanisms, mutants and semaphores. Non-blocking input-output to improve performance. Implementation considerations are system calls usually in C and C++ for lower level control. Efficient data structures and algorithms are crucial. Debugging kernel code is complex and requires special tools. Conclusion: system calls provide the controlled access between kernels. Application: system programs extend OS capabilities. Good OS design prioritizes efficiency, security, reliability, modularity, and concurrency. This coming to the end of the session. I thank you all.